This is a video covering assignment 15 in test prep, dealing with straight percent calculations and percent change calculations. And if you'll just commit a couple of simple things to memory, really the part over whole idea is the whole idea here, and then these other things are just the manipulations that would result. Or you just translate the problem. Sometimes translating is a lot easier. So student earned a grade of 80% in a math test that had 20 problems. So we want to figure out what the part is here. So x over 20 equals, if you want 0.8, or you could say 80 over 100. So in doing 80 over 100, that is the 0.8. So I'm just doing that right side out. So you can put 80 over 100. And then it's a cross product, 80% of 20. And that is 16. 0.8 times 20. So that's pretty much, every time what you're doing. Number two, the part is 29, the whole is 36. Just be aware of that sometimes the part is more than the whole. Okay, that's like a kind of an extra credit type of thing that would be going at. What percent of 120 is 300? So times 100. So this would be 250. You could get, if you did this without the 100, you'd have 2.5. So in doing straight percent problems, there are three things to keep track of: the part, the whole, and the percent, and to know what it is that you're solving for. So problem 5 is a good problem. So the part is 49, the whole we do not know, received a grade of 0.98. So again, I'm doing this 98 over 100. So what is the grade? So it's a cross product. And then divide both sides by 0.98. So 49 over 0.98 is 50. Bam. Okay, so straight percent, no giant things there. This is the major idea when dealing with things, but just part over the whole equals the percent adjusted, if you want to use it as a decimal. All right, the back. So here's the giant thing. The best thing to do is to come up with what I call the multiplier when you're figuring out the new amount. And typically it's just one time, but I have another one because it can be more than once. This first one, you do a ton of. The second one, not so much, but you need to know it. It's the difference over the original times 100. So you see on number 1, the difference is 10 over the original times 100. That's when you want to know percent increase. So make sure, this has probably got rounded, I'm just looking at it here. Oh, I'm sorry, about 11. 11 over 74 times 100. Always check your work. There we go. So yep, it got rounded to 15 in that. So difference over the original times 100. The other thing is to just use what I call the multipliers instead of doing it the hard way. So you are at a restaurant, you want to leave a 25% tip. The bill is $34.75 and 4% tax is applied, and then the 25%. So what are you actually doing here? You're doing $34.75 times 1.04 times 1.25. Those are the multipliers. Where did I get 1.04? Well, that's 4%, 0.04 added to 1, because it's an increase. If it was a decrease, we would be multiplying by 0.96. Same way with the 25% tip, that's an increase. So it's what you're multiplying by 1.25. So you go left to right, and you get 4518 when you do that. Again, rounded off to the nearest. In the previous problem, what is the overall percent increase after you pay the final bill? So there's two ways you can do this. I like multiplying the two multipliers out. So 1.3, but you got to figure out, okay, what got added to 1? And that's 30%. You could also do the 4518 minus the 3475, get that number and divide by 3475, either way. So know how this works. Problem 8 is very interesting. You have $100, and this is where this gets into exponential growth with the same multiplier over and over. You're applying a 12% increase 50 years in a row. So instead of multiplying by 1.12 50 times, you can see up here, this over and over, you do that. So percent increase and decrease with the same multiplier is exponential growth and decay. Percent increase and decrease with different multipliers is just that. Percent increase and decrease with different multipliers. So that's where I wanted to relate that with that. But there's so many people that will just refuse to use the multiplier, and it's so much easier. Here I am at a restaurant. My bill is $79.25. And I want to give the awesome waitress a 25% tip. Then I have $99, $100. Okay, so use the multiplier all the time. I got $80 and I want to do a 10% discount. So 1 minus 0.1. All right, so that is percent increase and decrease, and then straight percent with the part over the whole concept.